Here we have a Hohner Pianet T. The chrome furniture is a bit rusty, but it looks in reasonable condition. It's been stored in a barn for years, but the keyboard looks fine. These are electromechanical with a pickup, so it should make a sound when played. It's clunky and out of tune, but we'd expect that. The cover is held on with 3 screws, which have cup washers we don't want to lose. The other 2 came off with the screws. Let's lift off the top and see what it's like. The mechanism consists of 61 keys, which are arranged on rockers. Each key has its own pickup, the coils of wire, which are all connected in series and end at an impedance matching transformer. Each key plucks a reed or tine whose vibration is picked up by the coil. The pickups look fine, nothing is broken or missing. The reeds at the back have surface corrosion and the key mechanisms have some too, but that will clean up fairly easily. So, how does it work? The rubber pad lifts the reed until it unsticks. This mechanism is described in a 1961 patent. The patent refers to the original design, which used semi-absorbent leather pads. The 1973 T is a next generation design. However, the principle is the same. If we remove the pad, you'll see that the surface is shiny, except where it was resting on the surface of the reed. The reed is secured to a brass post by a screw. It has some type of blue lacquer coating which has succumbed to surface rust. The reed has been coarse-tuned by filing the edge and then fine-tuned by removing material on the flat. A brass weight has also been added, and that's been filed too. The underside of the reed is better than the top. You can tell by the angles of the marks that these have been tuned before being installed, and this has been done with the reed upside down so that the filing marks are not visible when the reed is fitted to the instrument. The surface cleans up well with a fingernail, but the pitting will be an issue. It will likely affect the tonal quality of the reed. And we must create a smooth surface for the rubber pad to rest on, otherwise the polymer attraction mechanism won't work. Now I've put it back together, that key does not work, because what little polymer was on it has been wiped off.
So, where are we? Well, we're back in my office and we're making a plan. Contrary to popular belief, I'm not as stupid as I look, and I would never have taken that key to pieces if I wasn't sure that I could get replacement silicone oil for it. The 50,000 to 1 million centistoke polydimethyl siloxane oil, PDMS oil, which is quoted in that spec, was really for the original 1960s instrument that had leather pads. We now have a 73 model which has the rubber pads instead, but the principle remains the same. Now, high viscosity PDMS oil is really hard to get. I looked everywhere for it. You can get it, it's used in automotive applications, and it's also actually used in food as a release agent for baking tins. However, that PDMS oil is sort of 200, 300, 400 centistokes. It's a thin liquid. It's a couple of orders of magnitude away from where we want to be. However, a little bit of research revealed that radio control enthusiasts use high viscosity silicon oil, which seems to be PDMS, in the differentials of model racing cars. So I've ordered myself some 500,000 and 1 million centistoke PDMS oil, which I think is going to turn out to be more like a thick paste or thin paste than an oil. And we'll try some of that, and we'll see what happens with it. The surface of the reeds, I'm not convinced about. People will say the surface doesn't matter as long as the landing area for the pad is clean. I'm not convinced. I think it's going to affect the total quality of the reed, and I'm not really happy to leave it that way. I'm going to try cleaning that surface rust off, that surface corrosion off, along with the lacquer that's on there. And then I'm going to treat them with phosphoric acid to convert any little bits of iron oxide that are left in the pits into iron phosphate so that they don't corrode anymore. And then I'm going to do a chemical bluing of them. That will create a surface finish that should be a little bit more resistant than just leaving them open. It should be as good as a lacquer, especially as they'll pick up tiny traces of oil as we handle them, and that should be pretty good. So we'll see what happens with that. When we go back to the workshop next time, we're going to put that instrument on a frequency counter and an oscilloscope to see what it looks like now, and then we'll see what it's like when we finish doing that read. So that will be the next job. Join me next time, and in the meantime, I await the postman.